Good morning to all. This is Rachana, Assistant Professor of Mathematics, Institute of Aeronautical Engineering. Today I want to discuss about elementary transformations on a matrix. After that we will take the Echelon form. By using Echelon form we will find the rank of the matrix. Rank of the given matrix of order anything, either square matrix or rectangular matrix. First we should know about elementary transformations. What are the elementary transformations of the matrix rows and columns? How we can apply transformations in the rows as well as in the columns. So elementary transformations on a matrix. Here we have to take three steps or three different types we have to interchange rows. The first step is nothing but interchanging of ith row and jth row, and it is denoted by Ri interchange with Rj. What about these I and j? I nothing but any row and j nothing but another row. I want to interchange first row and second row. So we have to interchange each and every element in that row. Suppose in any matrix 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the square matrix. I want to interchange two rows. Any two rows I have to interchange. So here I'm first row is I'm taking R1, second row is I'm taking R2, third row is I'm taking R3. So in these three rows, any rows we have to interchange. In a row, each and every element must be changed. So I want to interchange R1 and R2. So I'm writing here R1 interchanges with R2. So the equivalent matrix, after writing the next matrix, we'll take equivalent. So this matrix is equivalent to given matrix. That's why I'm writing here equivalent symbol. So now here I'm interchanging R1 and R2. Here R1 is 1, 2, 3. R2 is 4, 5, 6. Now I'm changing R2 is R1 and R1 is to R2. Then the matrix become 4, 5, 6 and the second row now 1, 2, 3. Now the third row is as it is. I'm not disturbing anything in the third row element. So write as it is third row. So the first step is here we can interchange any rows. Based on our convenience, I am interchanging R1 and R2. So each and every element should be changed. Now go for the second step. So generally I am writing here Ri implies Rj. Any rows we have to interchange. R1, R2, R1, R3, or R2, R3. Any rows we will change. Now second step. What is the second step? If ith row is multiplied with k, then it is denoted by k into some Ra. So I want some element in that row. So that's why I have to take some k element. Now I am multiplying each and every element in any row with this scalar k. K is here non-zero element, non-zero value. So by our convenience, I want to change one row, multiply with this k. So suppose for this matrix, I want to multiply 2 with R1 row. So I am writing here 2R1. Now R1 I am changing. How this R1 changing? 2 into R1. So for each and every element multiply with this 2. Then the matrix become, for this matrix I am taking 2 ones are 2, 2 twos are 4, 2 threes are 6. And second and next rows as it is. I am not disturbing anything in these two rows. So second row is 4, 5, 6 as it is. And third row 7, 8, 9 is as it is. So what is the second step? If any scalar value which is must be not equal to 0, we can multiply to any row each and every element. So then the matrix will write 2 into R1. Suppose I want to change R2 row. So multiply k with R2 each and every element. Or similarly use R3. K into R3. K is any non-zero scalar. I want to change R3 with this scalar. So take k into R3. So like that, the second step is if we want to change any row with the multiplication with k, we can write K into Ri. Generally, I am writing Ri changes to any row will change. So R1, R2, R3. If it is 4 by 4, R4. So any row multiply with this K scalar. Then we write generally K into Ri. What is the meaning of K Ri? Ri is the ith row which changes and multiply with this K. So then the equivalent matrix become K into Ri. The Ri row changed with the multiplication K scalar. Go for the third step. What is the third step? If all the elements of ith row are multiplied with this K. So I am taking any row, multiply with K, then I am writing K into Ri. Now multiply with the K to any row and add with the another row. So added to the corresponding elements of jth row. J nothing but another row. Then it is denoted by I want to take R2 changes. How R2 become change? K R1 plus R2. So I'm multiplying K in each and every element of Ri row plus adding with R2. Then R2 change. How R2 change? K R1 plus R2. Multiply first of all K into R1 plus add with the corresponding element in R2 row. Then the matrix become change. So then the row become change. Then the matrix is said to be an equivalent matrix. So we can follow these three based on our convenience. So first step is nothing but we will change rows. Any row should be changed. And second step is multiply with any scalar K to any row. And third step is multiply K to any row and add with the any another row. So these three steps we will follow. These transformations are nothing but elementary transformations of a matrix. Now here similarly we can apply operations to the column also. So here we have C1, C2, C3 generally. So we can interchange any two columns. C1 column, C2 columns, interchange. First step. Similarly, second step, we can multiply scalar to any column. In each and every element should be multiplied with the scalar. And the third step is we can multiply K to any column and add to the any column matrix. Add to the any column. So I want to take suppose to C1 plus C2. Then C2 will change. How C2 will change? 2C1 plus C2. Multiply 2 with C1 each and every element plus add with the C2 column. So then the column C2 column will change and the remaining columns or remaining rows as it is. Wherever we are applying either addition or subtraction, whatever it is, then remaining all are as it is. Only those columns or those rows should be changed. So then the column, if we apply column operations to the matrix, we write Ci interchanges to Cj. Means any two columns are interchanged. And the second step is Ci interchange to K into some Ci. And the third step is Cj. I want to change Cj. How it will change? Cj plus K into some Ci. Multiply K to any column plus add with the another column. Then Cj will change. So the elementary operations and a matrix do not change its rank. So our intention is to find the rank of the given matrix. So for 3 by 3 and 4 by 4, it is very difficult to take determinant. So that's why we will use elementary transformations to find a rank. So now go for the method Echelon form. By using Echelon form, we will find the rank. So before going to know that, we should know equivalent matrices. So where the A and B are equal, given A is matrix of order anything. Now after applying some elementary transformations, we'll get another matrix B. Then B and A are equivalent matrices. If B is obtained after a finite number of elementary transformations on capital A, then B is said to be equivalent to A, and it is denoted by B is equivalent to A matrix. So if A and B are two equivalent matrices, then rank of A is equal to rank of B. So that's why we apply some elementary transformations on the matrix A. Then the resulting matrix here will get B. Then rank of B is nothing but rank of A also. So why? Because B and A are equivalent matrices. So rank of B is equal to rank of A. Now if A and B have the same size and the same rank, then two matrices are equivalent. So definitely we'll get A is order 2 by 3. Then definitely the equivalent matrix B also having same order. Then if rank of A is equal to rank of B, then we say both A and B are equivalent. Now Echelon form of a matrix. By using Echelon form, we will find the rank of the matrix. So what is Echelon form of a matrix? So which matrix is Echelon form and how we can find rank by using these Echelon form and all we have to discuss now. So a matrix is said to be Echelon form. So where given matrix is A, which is any matrix, either square matrix or rectangular matrix, we can find rank by using Echelon form. So what are the steps and how we can change the matrix A into Echelon form? Here we have some conditions. So first condition is 0 rows, if any, they should be below the non-zero row. So if any 0 row, in that row we have all the elements are 0 rows. If any 0 row is there in the matrix, that should be after the non-zero row. So 0 row is, we cannot consider like this. So here 0 row is the second row, but after 0 row we have non-zero row. So we have to interchange now R2 and R3. If any 0 row is there, that should be after the non-zero row. Here we have to remember one thing. What is 0 row and what is non-zero row? 0 row means in that row all the entries are zeros. Non-zero row means at least one entry or one element in that row is not equal to 0. Suppose in this last row I am taking like this 0, 0, 0, 4. The third row is again non-zero row. Why? Because here we have 4. In this row we have one non-zero element. So that's why which is non-zero row. And second row having all the elements zeros. So which is 0 row. And first row anyway we have all the elements are non-zero elements. So the first row is non-zero row. So what is the first step? If any 0 row, that should be will write after the non-zero row. Go for the second step. The first non-zero entry in each non-zero row is equal to 1. So non-zero row. What is non-zero row? If at least one element in this row must be not equal to 0. So I am taking second row like this. 0, 0, 2, 2. And next row I am taking 0, 0, 0, 1. So what is the second step? The first non-zero entry in a non-zero row is equal to 1. So this is the non-zero row. The first entry is here 1. So similarly second row I am taking. In the second row the first two entries are zeros. And next two element should be make it as 1. And the third row. In the third row we have 0, 0, 4. So this also we have to make into 1. So whatever rows, non-zero rows, the first non-zero entry should be equal to 1. We have to make that non-zero entry is equal to 1. Go for the third step. What is the third step? The number of non-zeros before the first non-zero element in a row is less than the number of such zeros in the next row. What is the meaning of this? So I am taking one matrix like this 1, 2, 3, 4. Here I am taking 0, 0, 1, 2 and next I am taking 0, 0, 3, which is a matrix and which is Echelon form I am saying. Why which is Echelon form? First row and first condition is what? If any 0 row, that should be we have after the non-zero row. So in this matrix there is no 0 row elements. There is no 0 rows. So and the second step. What is the second step? If any non-zero row, the first non-zero element is must be equal to 1. So first non-zero, first entry is again 1. In the second row, the second element, third element is 1. In the third row, I'm taking 0, 0, 0. Suppose I'm taking in place of 3, 1. All these are non-zero rows. The first two non-zero elements are here 1. And what is the next step? Third step, third condition. So zeros, if any, those zeros must be less the next row zeros. In the second row, I am having two zeros. In the third row, I am having three zeros. So number of zeros in the second row is less than the number of zeros in the third row. So now which is a echelon form, and finally we take number of non-zero rows. How many number of non-zero rows here? 3 non-zero rows. The rank is nothing but here 3. Like this, we have to change the given matrix into echelon form. Finally, the number of non-zero rows indicates the rank of the given matrix. So here we have one condition. The number of non-zero rows in echelon form of A is the rank of A. And the rank of a transpose of a matrix is same that the original matrix. And here one more. The condition 2 is optional. So always no need to make this non-zero element in any non-zero row is equal to 1. Sometimes we take as it is another 1 also. So there is no change. So for our convenience, we have to make non-zero row, non-zero element is equal to 1. This is our convenience only. We'll change that into 1. So the second condition is here optional. So whatever the given matrix of order anything, either square or rectangular, the first step is nothing but we have to remember if any zero rows are there, that should be after the non-zero row. We have to kept in the after the non-zero row. Second step is nothing but in any non-zero row, the non-zero element must be equal to 1. This condition is optional. And the second condition is nothing but number of zeros. In the second row, here we have two zeros. Two zeros before the non-zero element we have to consider. So here non-zero element is 1. Before non-zero element zeros are we are considering. Here we have two zeros before the non-zero element. And in the next row we have three zeros. So number of zeros in the second row are 2 and number of zeros in the third row are having 3. So 2 is less than 3. Number of zeros in the second row are 2. Number of zeros in the third row are 3. So 2 is less than 3. So third condition also satisfied. Now we will count the number of non-zero rows. Here the number of non-zero rows are 3. Then rank is 3. So like this we have to change the matrix into echelon form, then find the rank. So these are the two examples of echelon form, and here we are using only row transformations. That's why we call here row echelon form. Here we are not using any column transformation. We have to make the matrix into row echelon form. So that's why we are using only row transformations. So in the first example, here we have 0 row, that is after the non-zero row only. And in the second row we have 1 0. And the next row we have 2 zeros. So definitely which is a echelon form. And the rank is here number of non-zeros. How many number of non-zero rows? Here we have one entry. So that's why 1 row, 2 row, 3 row. How many non-zero rows? 3 non-zero rows. Then rank is here 3. Rank of A we are denoting row of A. Row of A is nothing but rank of A. Rank of A is here 3. So similarly, take the second example which is also in the echelon form. Why which is in echelon form? 0 row which is after the non-zero row only, and the number of non-zero rows are here 2. First row having one element, second row also having one element. So definitely 2 non-zero rows are there. So then rank is here 2. Now take one problem. Find the rank of the matrix capital A given 2, 3, 7, 3 minus 2, 4, 1 minus 3 minus 1. By reducing it to echelon form, we have to apply only row transformations and change the given matrix into row echelon form. So for that, write the given A, which is under 3 by 3 matrix, applying row transformations and capital A. So what is the first step? Better to take the first entry is 1. So then we will change the remaining elements are zeros. So for our convenience, I am changing R1 and R3. Why R1, R3? In the second row we have 3. So no need to take 3 in the first place. So if we want to take 1 in the first place, it's very easy to make remaining 2 are zeros. That's why I'm interchanging R1 and R3. So first row and third row both I'm interchanging. The first row is 237 that I'm writing in the third place. Third row 237 and the first row become 1 minus 3 minus 1. I'm interchanging R1 and R3 rows. And what is the next step? By using the R1 elements, make the remaining 2 are zeros. What is the Echelon form? If any non-zero, the first elements are should be 0. That's why by using this one, I'm making these 2 are zeros. So that's why R2 I want to change. R2 how? R2 minus 3R1. Multiply 3 into R1. Take plus R2. Then you will get 0. 3 minus into 3 into 1. 3 minus 3 will get 0. Similarly, third row. How R3 change? R3 changes to R3 minus 2 into R1. 2 ones are 2. In R3 again we have 2. 2 minus 2 will get 0. So the third row first element will get 0. By taking the transformations R3 minus 2 R1. So we'll get 1 minus 3 minus 1 and remaining minus 2 minus into minus plus 3 3s are 9. So we'll get 7 and here 4 minus into minus plus 4 plus 3 7 and next is 0 and R3 minus 2 R1. We'll get last row is 0 9 comma 9 and 9 and R3 changes to R3 minus 2 R1. So like that we'll get matrix and take another transformations. This is not a Echelon form. What is the Echelon form condition? What is the third condition in the Echelon form? If any non-zero element before 0, that should be less than the number of zeros in the next row. In the second row, we are having only 1 0. And the third row again having only 1 0, which is not a Echelon form. We have to make third row, this second element also 0. So for that, I am taking R2 by 7. First of all, for our convenience, I am taking R3 by 9. So we'll get 1 minus 3 minus 1. In the previous, we have last rows are 9s and the second rows are 7s. For our convenience, I am taking R2 by 7 and R3 by 9 to get 1. So that's why I am taking R2 changes to R2 by 7 and R3 row changes to R3 by 9. Then first row as it is, I am not disturbing first row elements. 1 minus 3 minus 1 as it is. And the second row 0 1 1 and last row R3 by 9 will get 0 1 1. Now our intention is to make this third row second element is 0. That's why I am taking R3 minus R2. If we take R3 minus R2, 1 minus 1 will get 0. 1 minus 1 is here 0. And 1 minus 1 again will get here 0. Now which is in Echelon form. Why which is in Echelon form? Take the number of zeros. In the second row we have 1 0. In the next row we have more than 1 0. And here the first condition also satisfied. What is the first condition? If any 0 row is there, that should be after the non-zero row. Now we can stop here and which is in Echelon form. Now take the number of non-zero rows. How many number of non-zero rows here? 1 minus 3 minus 1 first row which is non-zero row and the second row is 0 1 1 which is also non-zero row and last row all the elements are zeros. So here we have only 2 non-zero rows. The rank of the matrix A is nothing but number of non-zero rows. The number of non-zero rows are here 2. So therefore rank of the given matrix A is 2. So already I said after applying finite number of elementary transformations we'll get one matrix B. This B matrix and the given A matrix both are equivalent matrices. The number of non-zeros here 2, then rank of B is nothing but 2. Similarly, rank of A also 2. So rank of A equal to 2. By using Echelon form, we will find the rank of the matrix of order anything, either square matrix or rectangular matrix. Hope you are all understood this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.